The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Good morning to everyone. It's really a pleasure for me to be here. I want, before starting, recognizing the presence of Jim Cagley back there. And the reason I say that is because last night there was a function honoring the founding fathers of the foundation, ACI Foundation. Very important for ACI, promoting students to participate in ACI and helping them their studies. So, Jim, we honor you. So I'm always, for other reasons in my life, for the last 30 years, I've been involved in the restoration of historic buildings. I'm talking buildings of 16th century, 17th century, 18th century. At the same time, I've been involved in doing special structures in Puerto Rico, shells, etc., all those things. So they called us to do an evaluation of a building that was built in 1904. It's a mixture of clay bricks, concrete, and steel. And that building, they called us because there were some concrete columns that were having failures, and the cover was coming out, and rebar was showing, and there was some corrosion on some areas. And when we went there, said, listen, you have a bigger problem than the column was spalling and some corrosion. This here is a really very damaged building over the years. So we propose you follow, allow us to follow ASCE 31 and 41 to do an evaluation, to be able to put the buildings or the complex of buildings in a condition that would last another 100 years. We make a presentation to the president of the university, and they allow us then, and they pay for us to be able to do that. And I'm going to talk about that at the end. So we could not only detect the efficiencies of the complex, but in addition to see and evaluate the potential strengthening of the building in order to perform. Do we have, oh yes, pointer. This is the 1904 building. And it has several expansions. We'll talk about it. But they asked us, since we were going to do this, to do the same kind of study to other buildings, the San Jose building, San Miguel building, the residence hall, etc., which are concrete buildings that were built, over the 20th century, attached somehow to the original 1904 building. There are no joints whatsoever between any of the buildings, so you can imagine how difficult things get. We discuss with them, and they allow us to do it, to do the preliminary evaluation. And as you know, you review construction drawings, the visual inspection of the buildings, then some quantitative comparison of codes. As you go back to the old buildings, you say, well, it will be more difficult. As you go to the newer buildings, you will have more information. Wrong answer. The newer buildings, the less information we had. We were able to find the construction plans for the 1904 buildings. Some of the buildings done in the 70s and 80s. Nobody has an idea where the plans were or what they did. And so there was a program for us to do an as-built of the building. So we did both the architectural as-built and the structural aspect, because there was no idea what the structural systems were. So it was a tough start. Then the comprehensive evaluation, as you know, then goes to source and material testing, some analysis, the preparation, and it is being guided what we found in the preliminary evaluation. Because there's seven buildings in terms of what the university thinks there are, 7 buildings. It will be too long for the short 25 minutes I have. So I concentrate in the main building, the 1904, that's the presentation, and 1906, I'm sorry. And that building has had several additions up to the year 2000, which was the last addition. So in order to be able to perform a Tier 1 or Tier 2 analysis, we have to subdivide the building into what we believe was the construction stages, because some of them we're not even sure after several months of studying. So we call them subgroups, and that's how we started the group. To give you an idea, this is a photograph for about the 1950s, or what was the original 1904. So, but you can see now in the modern photograph that there's some strange things, some weird things happening up there. And if you go to the back, it's even worse. But I didn't put the photo of the back because it makes you cry. Such a beautiful building on the front. Anyhow, so then this is the 1906 plans. They existed. It was in the archives of the university. And basically, it's, the original building was built with some concrete columns. Some of there's a chapel. We'll go into that soon enough. The chapel was made, the columns out of concrete, but instead of rebar, they have steel shapes inside the columns. And the floors were made out of steel beams, but the steel beams were encased in concrete. I've seen that in several buildings in Puerto Rico from about 1910 to 1940. They would use steel shapes, but they have these forms that they would do a rigid diaphragm with rebar, but then the beams will be, the steel beams would be inside the concrete, and I'll show you some pictures later. So basically, it was a very simple design in those terms, but thanks God to the original plans, we were able to have information on the original building. So we went into the trouble of then trying to identify the phases of constructions of the different subgroups. So basically, what we see here in yellow, bright yellow, was the original 1906 building. And we assigned different colors to the different times of the different construction eras. And most of them are on the lower level. The building is in the top of the hill. As it goes down in the back part, all this mess was constructed. A radio station, a TV station, a computer facilities, etc. Yeah. As you go up, you now can see the chapel, what was built on top of it, and you can see the different buildings. The green building was the newest one. The areas marked as green are the ones that were attached to the main building. Already were reinforced concrete development. Only the area back here that is blue has steel beams and concrete floors. As you go up, this is empty because this is a beautiful chapel, and this is 3 levels high with a beautiful shelves. This is an addition. This is one of the worst parts of the construction. This was an addition to improve the area for the priest, to have more room, and then some more rooms in the back, and some more another library in the building. And then this is the roof of the chapel. Then some more. This was a college run by nuns the first 60 years. So they built more rooms for more nuns. And the same thing happened on the upper floor. That thing that you saw from the front picture were more rooms for nuns that they run the school. It used to be a school for girls only until around 1980. Then it became a university. Today is the Sacred Heart University of Puerto Rico. And so, and this is one of the worst quality construction part. Was apparently done without no construction plans. They would do some more rooms, and someone got there and just did them. So, in terms of the rapid visual screening, as we went through the building, it was very difficult. We lose a lot of money on that first part because it is very hard to deal with the university and the professors and the employees. This is the administration buildings, and because of different additions, the floor height is approximately 16 feet, but in many areas there was some acoustical ceilings installed during the different stages. So in order to do a structural as-built, you have to coordinate when a room was accessible and when it was not accessible. And but because we were interested on the bigger job, we just hang in there, looking forward to do it. But it really, we thought we could do it in 2 months. It took us 6 months to be able to finish a structural as-built of the administration building alone, because of the coordination and the professors, etc. So as I always like the FEMA, this FEMA form, and I think it gives you a quick and simple way of seeing how bad things are. I know everyone can see every single number is there. So for that reason, because I am past my middle age, I understand some other people are, so I do larger regions now. So basically what this method does is you choose what type of building just to control. In this case, we separated and did a visual screening for each of the subgroups of the building. This is the unreinforced masonry part, okay? And what you do basically is that you choose what applies or what doesn't apply to your building. A basic score for an unreinforced masonry is 1.8. Everything below 2 points, you're required to do further studies. If your score by the visual screening is above 2, the building should be okay, according to the process. But we started at 1.8, so we already are struck there. But in addition to that, we have vertical irregularity, we have plan irregularity. It is a pre-code building, and we are on a stiff soil area. So our final tally is minus 0.5. So it cries, and shouts, "Help me, help me!" That's the process. So, but the things got worse because we thought, well, that's for the masonry building. We'll improve as we go on. Nothing to do. So this is what we believe was the second construction stage of this complex. Some alleys to each side of the patio at the lower level of the chapel, and additional rooms in the back, and the first lower level building on the lower floor. But as we go, and we did the same thing, minus 0.9, minus 0.3. The thing is, you see 2 scores here. It's because this visual screening doesn't allow or doesn't take into account mixed systems. So we decided to evaluate both systems that the expansion has. So that's why we choose reinforced concrete and why we use shear walls. And as you see, it starts in 2.5, but as we go down, there's a lot of negatives because, as you can see, just by the plan, the irregularities are tremendous for what they did. So there's a lot of negative points in plan irregularity, vertical irregularity, pre-code, soil type, etc. So even the newer additions made in reinforced concrete, both turn out to be on the negative side of the punctuation. So again, it was crying that you need some help. So this is the process, and this I cannot follow it large enough to do. But at the end, what this tells you is, I'm not going to follow it due to time, but it's a very simple process. You go, when do you need what, or what do you need? I think it's a great guide. I know there's some critics about this process that takes too much out of the engineering judgment. I think that with good engineering judgment, this is a great tool because lawyers exist. And at the end, some years from now, something is going to happen that I follow a process. And I think there's some logic to, a lot of logic and input. And as ACI and ASCE now are working together in improving these standards, it will be even much better, as we have gone in Committee 369 reviewing this stuff. So I understand the critics, but the worst thing is doing nothing. I was 3 years ago invited to Turkey to give a presentation of U.S. codes and historic structures. And it really makes you cry of what poor guidance actually is given in all the codes in America in terms of what to do. The historic buildings are there. They are reality, and they are the patrimonial history of our country, and we need to preserve it. So sorry for the guys who are always saying no. I think this is good. So there's another federal evaluation requirement that you need to do and in order to follow the process, and basically it goes again on where is a low, medium, or high seismicity area. In the case of Puerto Rico, it's high seismic area. And then this is a very important decision, whether you're talking about the building for just life safety or for immediate occupancy, which is very, very different in terms of what the more strict requirements are imposed on the structure. Most buildings will only require life safety. You want everyone to walk out after the earthquake strikes. But as you go into schools or you go into hospital facilities, you really need to be in immediate occupancy mode, because they will be required after the damage. So we go through a process. I'm not going through the numbers, but it's just a simple way of, depending what you have, you choose what the values are for your particular building. Then you try to see if there's some other deficiencies, and an ASCE 31, so the Tier 1 analysis, you determine, depending on what is your system. Again, we're talking now about 1906 building, and if it complies, no. So there's a list, and you check whether it complies or non-complies, or whether that option is not applicable. So there's a long list of things in terms of the building systems, in terms of the lateral force, the connections, etc. And then there's some supplemental structural checklists that, because the building has so many deficiencies, you have to go to the next level and keep on looking for more deficiencies. At the end, we found in the building over 200 deficiencies, according to the program. So although from this rapid visual screening, you could determine that, just in case. Remember, you have to convince an owner that there's a lot of money that has to be put into the building. And so in my opinion, I'm the one that sells the projects to the owners in my company. This is very important, because it's not, well, we did a rapid visual screening, and we found that your building is deficient, and we need to do some more studies, and you need to pay me more. But when you go with this checklist and say, well, we went through the checklist that the ASCE and the FEMA value has, and you have 200 deficiencies. Oh, that stuff's. And that's a reality of life. Just to show you some stuff, this is part of the rebar that got spalling, etc. But this is one of the craziest and worst part that we found all around the building. Every time there was a new air conditioner installed, whatever, they did whatever they wanted. Nobody cared whatsoever in the maintenance division of the university. And they suck. And there was even some portions that there's a hole already here, but they make a new one next to it. Yeah. Oh, there it is. You see? So we thought architects were worse. No, the truth is that for structural engineers, mechanical engineers are the worst. So you see here, these are openings on the masonry walls. As a matter of fact, we just finished repairing one of the portions. And we made some wood frames, and we repaired the masonry, etc., to give it more integrity. But it really is really sad. And what this produced is that there were cracks on the original arcs, because of all this mutilation that happened in the building. Then there were some areas where they have high rip with plaster, with gypsum plaster and stuff, and some of them have cement plaster. And there was a leakage at some time. It fell down. They corrected the leakage, but then they put an acoustical ceiling because it looked too bad, but they leave it like it was, and never a repair was done. More bar corrosion. Oh, this looks looks better in my screen than your screen. See, this was the column that initiated the issue of calling us to see the building. They were terrified. And as you expect, there's not too many cross ties, or well, actually no cross ties, just some stirrups and some of the bars there. And we found pre-deformed bars, we twisted bars, all the whole collection. And you see here, this is the steel beams encasing concrete. When at some point there was some, they poured concrete from the flanges up, but the bottom part they put high rib with cement plaster. Again, when corrosion started in some of the areas, that high rib started falling down. Again, they just put some duct tape and then put acoustical sealing, and that was the way it was resolved. Then there's some of the areas. This is where the TV station was done. It's a modern construction, quote unquote, of the 70s. It sucks. The way that the impermeabilization was very bad. They had some problems with the air condition that created a lot of the humidity in the plenum, and because of that, basically all the structural steel that was installed for the slab is fully corroded. And then this is the point where you don't repair or make any tier 2 analysis or recommend any kind of analysis. The best advice to your client, this portion is cheaper just to destroy and redo again. Just don't lose your time on that, and that just go ahead. Although it's maybe a sensitive for some industries and hospitals, and you may need to go to extreme repair, but for a school, just move the students to someplace else, redo it again, and forget about it. And so just, you see here, this is a twisted bar. I don't know if the younger crowd here may have never seen a twisted bar. It used to be square bars that were twisted to create the bond. This is corrosion on the beams, on modern expansions. You see the cracks, again, for corrosion all around the building. Some more columns with spalling everywhere. And then this is remember the green portion that I showed you was the second expansion. So the left side, there was an additional rooms, etc. My conclusion after we did some tests is that the expansion was built with sand from the sea. They didn't use the ready-mix producer. They used sand from the sea because the level of corrosion and the level of chlorine content on the matrix is unbelievable. And again, this is a sad part. You can see here, this is the architectural decoration of the old facade. And they left it there and built the next rooms. And so this portion, again, our recommendation is to tear it down. And in my opinion, not build it back. And even in the nuns' room, the area, our recommendation, tear it down. No longer nuns lives there. And repair it for what? They cannot get classes or use their rooms. These are nun rooms. There's about, I don't know, they're 8 feet by 10 feet or something like that. So it really makes uglier the original building. Why go the trouble at all on repairing those portions? So, like in this addition, our recommendation, and we have the owner almost convinced that they will tear that down, and we'll cross our fingers that they will. So, in terms of the main administration building, outdated, substandard construction, age-related deterioration, damage during building modification, as we mentioned before, and in general, very bad judgment from the administration in the university. It's a beautiful campus. It's a very large campus, and yet instead of preserving and this beautiful building, they keep adding stuff. In terms of code comparison, the evaluation concluded as you expected, and inherent very high seismic vulnerability. We estimated a vulnerability by a factor of 3, which is quite large. The RVS screening, the rapid visual screening, went on, as we show you, that would require further evaluation. And from the evaluation of construction drawings where they happened, everything is substandard. So all the scores of all the additions became in the negative side, which is outstanding. How bad can things be done? And let me tell you, although I'm not talking about the other buildings, the more modern buildings, the San Miguel Mir building, the San Jose building, which are modern from the 70s, they don't comply at all. It's negative results. Very poor judgment on the structural systems, and they were strong on one direction, very poor on the other direction, and stuff like that. So on this Tier 1 analysis, over 200 non-conforming issues, so we recommended that the Tier 2 started. For doing that, the estimate, and as it was approved, and it's now in the process, it cost $600,000 to do the necessary testing for the building complex. And there was one of the previous parts of this forum was a big discussion about the number of tests for each area, whether we do 3 or with 6. I strongly encourage that whatever type of concrete you're testing, you should have a minimum of 3. And not go for per floor. I think that's completely misleading. If you're checking the slab, do three tests on the slab. You're checking the columns, 3 tests on the column. Checking the beams, 3 tests on the beams. Just to have a redundancy, because it is in modern times and modern construction, and you find very large inconsistencies on results for concrete tests. And when you go to times where there was not too many inspection and not too many certified engineers, it goes even worse. So then this is a very important concept, what is called the incremental seismic rehabilitation. It will be of no service to the owner if we just tell them, close everything down and let's tear this building for 2 years and go ahead. They need the building. So it's very important to sit down, and we did, with the planning department of expansions, etc., so that we could coordinate. In the future, we should be able to finish all the Tier 2 analysis by the summer. We are finishing now the testing. Is to coordinate which areas we do first that will impact, and for one thing, the budget, and for other thing, impact the operation of the university. So as a matter of fact, when we were doing the rapid visual screening, there were some new labs being developed in one of the other buildings. So they asked us if we could do some strengthening in that project, although we haven't finished our job. And we modified the construction plans for the architect that was doing the labs, so that at least that portion has been strengthened already. So finally, because of the deficiencies, we need the other parts are 2.8 is the factor. We need to repair too. So the general next steps are the material testing, which we are on the way right now, and I think it's very important for the owner that you use your engineering judgment and make a chess game on telling this repair should go first, because nobody has an infinite pocket. They have a limited budget. They have to budget every year. You will help a lot the owner to say, let's do this in 5 years, or depending the impact, let's do this in 10 years, do stages. So you will be a lot of help. You have to understand that the owners are terrified for what you're telling them, that the building is in poor conditions, and you need to help themselves in determining how to use the budget, how to use the process. And so we are in the process because of the portion of the 1906. The building qualifies for some federal funds, so that's already in the process. That will help the funds that the university has for doing the restoration. So on the other buildings, we will be doing the testing following, once we're done with the administration building, and then we'll do by prioritization the repairs that will be done. So that's it.